Welcome and good day to our beloved lecturer, Dr. Sila Hayati. Today we are going to present our project for industrial automation. In this subject, we are given the task to design an application of an automated system in a manufacturing industry. So, in this task, we had choose the extrusion machine system as the automated system to complete this task. Before we jump into the detail of extrusion machine system, we must know about the introduction. For the introduction, automatic extrusion machine is one of the automatic machine in the food production. It is designed to meet the requirement of the consumer and more oriented on food industry, which is based on the mechanism that has been used in the automatic extrusion machine, such as compression, extrusion, and cutting. In the mechanism of compression, power of compression air in the pneumatic that used for mechanical work is based on the electricity consumption of compressor. The extrusion process are one of the most continued processes used in the manufacturing of long products for the life cycle of the industrial application. There are different approaches of extrusion process built upon either the final shape of the product to achieve or the maximum loading capacity of the equipment to be worn. So, in this project, we are using the programmable logic controller, which is PLC, due to the ease of controlling different units with simple logic control. So, this is the list of components of our PLC for the automatic extruder machine. First, we use the push button. This is the symbol of push button. The function of this component is start all the program in the PLC system. For the normally open push button, it allows current to flow when the relay or contactor is energized. Next, we are using the 5-way directional control valve, so this is the symbol of 5-way directional control valve. We use it because it can be resolved in huge force available to act on another valve. It also can be recycled or repeated after completing its task. The third component that we use is the magnetic proximity sensor. This is the symbol of the magnetic proximity sensor. So the function of this component is there is no power supply needed when the switch is off, and it will provide a real galvanic insulation. Harsh environment and the distance for detection can be huge. It can be used in a harsh environment. It is very suitable for checking the extension and detection of cylinder where the cylinder rod has a magnet attached to them. Next, the other component that we use is the double acting cylinder. So this is the symbol of the double acting cylinder that we use. So the function of this component is the output force can be extended and retracted. If one of the extractor where the thrust or output force are developed in both extending and retracting direction, it will create a higher force level that is more reliable and easier to control the system. Using this double-acting cylinder, force remains the same, though the use of the cylinder also can operate a higher output cylinder and making process will be more smoothly. Next, we also use timer on delay and counter up. These two boards of timer and counter is a controller device in PLC, but there is a different function, which is time on delay. The function of it is time. The timer can produce time delay or continue pass. It also the timer is selected to ensure the uniform flow. For the counter up, the function is to count number and receive the input signal. It also to ensure the number of time is parallel with quantity of the dough inside the basin. So we had know the list of components that we use in this project. So we continue for the process flow machine. Mainly, there is three components used in this system, which is there are loading cylinder, extruding cylinder, and punching cylinder. So let's see the process flow. When I start, the dough that has to be extruded is put in a container that has a hole on a required size, which is in the cylinder. There is a hole for the dough to be extruded. Next, we continue to the second process, which is the proximity sensor are placed to know the position of the cylinder, whether in extended or retracted condition. Besides, sensor also used to activate the timer and count for the machine. According to the input from the sensor and the program written, the loading cylinder will load the container that contains of the dough. Then the process continues with the extruding cylinder. Extrude the dough. When the process of extruding the dough, the extending cylinder will extend for 5 seconds, which is there is 5 seconds extending for the cylinder to extrude the dough out. And finally, the cutting cylinder will cut the dough that have been extruded. So after this process is finished, the step will repeat a few times depending on the count that have been set. After finish extruding, the extruding cylinder will retract and followed by a loading cylinder will retracted back to its position. Okay, now we continue with the PLC card. This is the PLC card for our project. So we continue for the input. So for the input, this is the level of start. This is the level start for normally open push button. The prox2 is the proximity sensor for cylinder 2. For the prox3 is the proximity sensor for cylinder 3. For prox4, it is the proximity sensor for cylinder 3. For prox5, this is the proximity sensor for cylinder 1. For the prox1, it is for the proximity sensor for cylinder 2. Next, we continue for the output. For the output, for the sol 1, this is the solenoid valve 1. For Y1, this is the coil to actuate the solenoid valve 1. For Y2, this is the coil to actuate a timer. For sol 2, here is a solenoid valve 2. For sol 3, it is for the solenoid valve 3. For Y3, it is for coil to actuate the solenoid valve. After done with all the component PLC card process flow, we continue for the simulation. Before we jump for the simulation, we must know all these 3 cylinders is in the retracted mode. For the proximity 1 and proximity 3, it will be inactive. So let's do this step by step. When the start button is pressed, the intermediate value Y1 go high, which gives an intermediate output Y1. When Y1 is high, it makes the output Sol1 go high, which in turn makes the solenoid control DCV switch on, and thus the loading cylinder will be extended. So we can see from here, the loading cylinder is fully extended. So when the loading cylinder is fully extended, it will make the proximity 5 active. This makes the intermediate output Y3 to go high. It makes the output solenoid 3 go high, which in turn makes the solenoid control DCV switch on and extruding cylinder will be extended. So let's see how it works. So after the extruding cylinder is fully extended, the proximity sensor 2 is activated. When the proximity 2 is active, then intermediate value y2 go high, which gives an intermediate output y2. When y2 is high, the timer will start. And the proximity 2 will disactive. This means the extruding cylinder will be extended for 5 seconds. So you can see from here, the timer is start and the proximity 2 is deactive. The cylinder is retract. So the cylinder is extend for 5 seconds according to the time. So after 5 seconds, the timer will be reset and intermediate output Y2 will shut down since the counter is at the voltage. The intermediate Y3 is high and activate the proximity 4, which makes the cutting cylinder is extended. When the cutting cylinder is extended, the proximity 3 is activated. When proximity 3 active, the cutting cylinder will start retract. When the cylinder is fully retract, the counter will start to count. So when it's fully retract, the counter is start to count. So after the cutting cylinder is fully retract, the proximity 4 is active and the intermediate Y3 will go high, then the extruding cylinder will go retract. When the extruding cylinder is fully retract, the proximity 1 will active and the extruding cylinder will expand for 5 seconds and the cutting cylinder will cut. The count starts when the cutting cylinder is fully retract. So this extruding and cutting process will be repeated according to the count that we set, which is 6. When the counter is finished, the cutting cylinder is fully retracted. It will activate the proximity 4. This will make the intermediate Y3 go high and retract the extruding cylinder. When the extruding cylinder is fully retracted, the loading cylinder retracts back since the counter already finished the count. So, as a conclusion, with the rapidly changing technology, PLC become more popular in the majority industry because of its huge benefits. The machine with a PLC system can perform the work of 3 to 5 people depending on the task. It also can save the cost of labor and energy saving. Can also be significant due to the lower heating requirement in automated operation. It also can improve the worker safety in the hazard of a factory environment. With the PLC ability to work at constant speed, it will be increased and the new product can be introduced faster into the production process. Hey guys, that's all from our group. Don't forget to stay at home and be safe. Don't forget to subscribe and like our YouTube channel. Bye.